Okay, good morning. So today we're going to do 3D Mohr circle. So don't worry, 3D Mohr circle is we're still dealing with circles. Does not mean that 3D Mohr circle we're dealing with a cube. I mean a sphere. Okay, so it's still 2D. It's still circles. Okay, so with 3D Mohr circle. Yeah, the analysis is again to determine the principal stress. The principal structure. Now, so we know that in real world, all our structure are loaded in 3D. Okay. Uh, some stress direction can be lower than the others. Okay, but whenever we draw, you guys have seen it before. I've introduced you to this before. We always draw an element. So an element we draw in 2D, which is a square. Now we're going to go into 3D. Okay. So I'm going to I'm not going to tell you the importance of it yet. Okay, I want you to go through the theory of it, and then I want you to see the importance of it, and I'll highlight it. Okay, so if we go into 3D Mohr circle, okay, so we have our, as usual, transformation x, y, and z. This is just to quickly recap. So we have an element over here. Okay, so this is our element. So in our element in 3D, we have stress x, we have our stress y, and then we have our stress in our z direction, and then we have our shear, right? So this is our shear on the the plane crossing the plane crossing the x-axis. Force is the y direction. Okay, so we know that this is shear yz. Okay, then we have another one over here. So for this case, we know that this is our shear, the plane crossing the x, the force acting the z. Okay, so likewise this, the plane crossing the x-axis, and the force or the stress acting in the x direction. And lastly, right, so in 3D, so this is shear y plane z direction, and this is shear plane intersecting z y direction. So in 3D there are 6 components. Okay, so 3 normal stress, 3 shear stress, and always the one with the biggest area, right, biggest surface area, this is known as our in plane. So this is our largest surface area, right? So we call it our in plane. So, and then the other 2 planes we classify as our out of plane. Likewise, this one is our out of plane. Okay, so we're going to look at 3 possibility. Okay, we're going to look at principality. But before we go on, I'd like to mention this. Okay, so if the orientation, okay, if the orientation or when the orientation of the element is such that the shear xy is equal to shear yx is equal to shear xz is equal to shear zx, and all of them yz is equal to shear zy is equal to 0, then the element, okay, then the element is at the principal plane. Okay, because you have what? Zero shearing stress. Okay, so let's look at, so we're going to look at a 3D element now. Okay, and this 3D element has no shearing stress at all. Okay, so I'm going to draw an element again. Okay, so we are going to draw an element. So the element now only has stress x, stress, sorry, I'm sleeping today. So we have stress x, stress y, stress z, and then we'll use this transformation. So what I'm going to explain now, all of them will follow this transformation. Okay, so for condition number 1, okay, so we're going to look at condition number 1. Right, where we have stress z is equal to 0, okay, and stress x is greater than stress y, and both are positive. Okay, so this is condition number 1, right? So now we're going to sketch out Mohr circle on this. Okay, so we're going to label this. This is our x, point x, point y, and point z. Okay, so we're going to draw our Mohr circle, 3D Mohr circle. Under this condition number 1, so this is our normal stress. Then we have our shearing stress. Element rotate clockwise at the top, and then element rotate anti-clockwise at the bottom. Okay. So we know that stress x line, right? We know that stress x line, z line will be on the axis. Okay. And then the next one, this one over here, this is our stress y line, and the last one, this will be our stress z line. Sorry, x line, right? And all of them have zero shearing stress. Okay, so for this case, if you look at the element of them where you have stress, the shear xy is equal to shear yx is equal to 0. We do not have any shear stress. Stress zx is equal to shear stress zx is equal to 0, and shear yz is equal to shear zy. All of them are equal to 0. Okay, so this is in fact orientated at its principal plane. Then from here, we know that at this point, this is our stress x, point x, right? And this is our point y, and this is our point z. Okay, so we know based on the element that our xy plane right? So this is our XY plane, and this one is in plane, right? Because it's a surface, bigger surface area. Over here, that is your XZ plane, and this is the out of plane. And likewise, what we have over here, and this is our XZ plane. Oh, something happened. Sorry. How did that appear there? Right. And then we have over here, this is our XZ plane. Is it XZ? Yep. And likewise, this is our out of plane. Okay. So if we look at over here now, we found our 3 points because they have zero shearing stress. And then we draw our first circle. We're going to draw our first circle. So this first circle, this is our in plane. So this belongs to our XY plane. And this is our in plane. Right? It's an XY plane because we are joining them at point X and point Y over there, or the circle intersect point X and point Y, because later on we're going to have some shearing stress be introduced. Okay. And then the next one is this circle over here. So this circle over here, I'm going to use a different color. This circle over here now. So this is our YZ plane. Okay. And our YZ plane is out of plane. And finally, our third circle. Okay, so this is our third circle. And now this belongs to our XZ plane, which is our out of plane. Okay, so I hope you can recognize the pattern, right? If the circle intersect the X and Y point, we call it XY circle plane. When it intersect the YZ, right? We at when this case we have the YZ, we call it the what? YZ plane. And the bigger circle intersect the what? XZ, that's why we call it the what? XZ plane. So now we can label. Okay, we now, so we will call this height over here, right? So this over here is our shear max at the YZ plane. Okay. And then the next one over here, this one we'll call it our tau max, and this one belongs to our XY plane. And the last one, right, this is our shear max And this belongs to our XZ plane. Okay. And the last one that we've drawn